And this is not hard at all. It's good practice for understanding what to do. This first tab is just an example. You can do this with me if you want to, or it doesn't matter. The two I'm going to grade that I'm not going to do anything with are the next two. So this is kind of cool. Take a look at this. This is rather interesting. These are the Olympic long jump winning length for the last gazillion Olympics. And notice the first year, 6.35 meters was the winning length. And then it just got more and more and more and more and more, which kind of makes sense. That's kind of how, people are always trying to one up themselves. And notice it wasn't every year though. Do you notice this year? 1948, it was 7.82, and then the next year it actually went down. So it's not like it consistently went up, up, up. But again, the question is that, is there a relationship here? Is it going up? It's certainly going up over time, but what shape might that relationship actually take? And so in 2004, it got clear up to 8.59. So that's amazing because it's actually 2 meters longer than the winning jump kind of back in the day. So fortunately, this is really easy. Again, though, the important thing here is to note that, we're talking about data where you have two lists of numbers. The date is an important part of this too. You could just list these numbers individually, but the date is paired with those numbers. So to make a scatter plot, super easy. You grab all the numbers. And same place we went for a bar graph. Up here under insert, except for we're not using the bar graph, we're using this one right here, which is the scatter plot. And generally speaking, you don't want to connect them like this. You just want the rough scattered numbers. So, and as I mentioned before, it's kind of cool that you can size this thing to be any size you want. So I can fit it inside a box like that. If I was doing a Word document and I wanted to fit everything in there, I could certainly do that. Welcome, Garrett. Notice in the later problems, as I said, build a labeled scatter plot for the data. You should understand that mine isn't really labeled right now. I will take the time to do that. In these machines, it's really cool, at least the newer stuff, because this little plus sign here, as I've showed you, allows you to add axis titles. And so now I kind of have everything I need, so I won't take the time to do this well, but I'll at least say long jump. And I don't have to say much down here. If I say year, winning length, if I was to do a good job, it'd be important to say that was in meters. Otherwise, people wouldn't know what it meant. Now it's really good. I will show you one thing that's kind of interesting. Notice that automatically it included kind of 0 down there. It always wants to start at 0. Yet notice there's a whole bunch of my graph that's kind of wasted. You don't need to do this, but it's just kind of cool to understand how, because I can't see it very well. So you can actually click, you can change anything in here. So if I click on these numbers over here and right click and go to format axis, so that's almost how you change everything. If you click on it, right click and say format, then you can mess with it. I'll do it again. So click, right click, format axis. Over here it says minimum is 0 and maximum is 10, like it did that for me automatically. But see, since the first jump was over 6, I could say, well, I'd like the minimum just to start at 6. So I'm going to override that. So notice it, now my graph paper isn't kind of wasted quite so much. In the real world, I'd say that'd be a significant improvement. You would want to control that, make that a little bit nicer. I can see there's nothing over the top of 9 either, so I could set the maximum to be 9 if I wanted to, I guess. Splitting hairs, but it's kind of cool to control it. So that's a pretty good graph now. I mean, it's boring. I didn't do anything with colors or anything of that nature, but at least it speaks, at least it's accurate. So scatter plot. Now, from what you don't have a whole lot in your chapter 4 assignment. Really, most of it just has to do with, and maybe you've already done it, most of it has to do with just kind of what this R value would look like here. The things I would hope you would take away from this from the start is that's going to be a positive R value because it's positively correlated. As the time got bigger, the winning length got bigger. So it's kind of uphill to the right. So it'll be positive. And then it's not nice and straight. Like there's definitely a relationship. There's definitely overall, 1 year is different than another. Notice oddly, the biggest year ever was actually that one, which is crazy. It's like that was the winningest of all time, if you will, the largest one ever. And that apparently was clear back in 1968. But there's definitely an overall trend, and that's what's kind of cool about this. So it's not perfect. So I'd expect to see an R value that was positive, but not huge. Like, I don't know, maybe 0.86, I don't know. It's not terribly scattered, but it's not straight. It's not going to be 99%. So we did this in your graphing calculator, but of course you can appreciate now, and all you have to do, and I won't do this, but all you have to do now to use this in a paper or something is just click on it, right click and say copy, and then I could go to a Word document and paste it in there and carry on. And so that's really cool. That's way better than your graphing calculator. That's why I want you to understand this. And it was actually less effort, and the graph looks way nicer. Second thing, after making a scatter plot, is you can actually put the trend line on it. So I'm showing you kind of the screen that you'll see here in just a second, but you can get it to display the equation, the y equals mx plus b equation. You can get it to display that, tell you what that is, the regression equation that we learned how to get our calculator to tell us. And then also we can get the, notice it says here, just make note of this, it says display the R squared value on the chart. Like, it doesn't give you the R value, it gives you the R squared value. I won't go into that. We'll have to square root it, in other words, to get R if we wanted it. Okay, so how do you do that? Let's see, what did I say here? We can ask Excel to form a regression line by right-clicking on any data point in the scatter plot and selecting Add Trend Line. So in other words, click the data, right-click, and right here it says Add Trend Line. And again, it's interesting to note that there's a lot of different shapes that you could actually use. But again, we're only worried about linear in this class. And I think that fits over here. I don't see that as curving. So select linear, it was already selected. And then down here at the bottom, I can say display the equation on the chart because I'd like to see it, and display the R squared value. That's what I'm saying here with these two notes. So you can look back at that and remember how to do it. And so bam, that's done. And then it's always a good idea to kind of do this. You can like move that around if you wanted to make it, bigger, because you got this wasted space over here anyway. So I might as well use it, make it nice and visible. So let's see, just for the heck of it. And so that your intuition is growing about this. Notice it says that's R squared, not R. So the correlation coefficient 0.8206. So I'm going to take the square root of that. Square root of 0.8206. That's 0.9059. So that's my R value, 0.9059. Is that what you thought it would be, like just looking at it? Did you think it would be lower than 90%? Higher? I thought it was going to be a little lower. I thought it was probably going to be like 86%, something like that. It's got kind of a line, sort of a shape to it, but it's not perfect. So just having a feel for, yeah, okay, that makes sense. That's like 90%. You might think that's kind of, higher than you thought it would be. But those are definitely kind of following the shape of a line. This is a great example of what regression is really for. And I don't know, is this really worth my time to type it over here? It's like it's just sitting right over there. X minus 23.857. Say it again. How did you put it in here? Yeah. Let's do it again. When I clicked on these, thank you for asking. So when I clicked on the data, right-clicked and said add trend line, I just went down here to the bottom of this, and I'm showing it right over here so you can see it. But I said display the equation on the chart, that little box, and display the R squared value. And so now they're on there, but notice it just put them in a spot where they're not really very readable. So fortunately, that's just separate, so I can, drag it and move it around. Does that make sense? Yeah. Thank you for speaking up. So now that's pretty powerful. I want you to think for a second about what the slope means, because this is something I'm going to be asking about in the other two problems. So we said that slope, I think I'm going to, I'll type it right here since you can see it. We said the slope was equal to the rise divided by the run, rise over the top of a run. And notice, we also said that the slope was the number in front of the x. So the slope here is 0.0163. Because this is something I'm going to be asking about on the rest of the assignment, 0.0163. So what's the meaning of that? Like, it's not just a number. What is the meaning of that? Well, because slope is rise over run. Notice the rise is meters. That's length in meters. That's what the y value is meters. And then notice the run is measured in years. So if I was to put units on this, given that this is rise over run, then the units for that would be meters per year. Do you agree with that? So now that you add those units in there, all of a sudden it's like, oh, I actually see what that slope is telling me now. Yeah. Did you do the calculation for slope? Or did you just... No, I stole it right here. In other words, because the equation, thank you. Because the equation is 0.0163x, we are learning, we're going to spend more time with this in the second hour today, but we're learning that that number right there represents the slope of the line. And you had Excel find that? Yes, and Excel just gave it to me. When I said display the equation on the chart, it just gave me the regression equation. Did you copy it into the regression equation box, or what's the equation that goes in there? That I just typed. Okay, which is kind of a waste of time because it's sitting right here. Does that make sense? Right? Excel did that when you clicked the button and then you just copied it. Yeah, that's exactly right. Excel gave me this for free, which is what your calculator does when you say, I want to do linear regression. It gave you the equation of the line that models this data. And this is just Excel's way of doing it. And because the R value is just the R squared. Yeah, let's do that one more time. So if I click the data, right click and say add trend line, this little menu comes up and I can say all different kinds of curves that I want. And notice over here on the graph, like there's nothing saying that's could be curved, could be straight, who knows? But we're only studying linear regression and that kind of looks linear, that makes sense. And then I want to display the equation on the chart. So there's my equation. And I'd also like to know what the R value is. So I'm just getting that for free. So I didn't do any calculations. So then I just came down here, and since I was sort of asking for the regression equation. I just said, oh, there it is up there. I guess I'll just retype it. And then since the R value, since oddly, Excel gives R squared, like your calculator gave you the R value, this gives you R squared. So I had to take the square root of that. By the way, you could get Excel to do this. Just as a side note, if I typed equals SQRT, that's how you get Excel to do a square root. And then if I typed, well, what it says, 0.8206, the square root of 0.8206. So that's how I got 0.9059 for the R value. So that means that's not a bad fit. It's not 98%. It's not perfectly aligned, but it's at least decent. And so we agreed that, and I'll show you something in just a second that's kind of cool here, but actually I'll show you right now. There's an online free graphing calculator called Desmos that's really powerful. Watch this. So if I say y equals mx plus b, what's really cool is you can add sliders for these. So right now, this is y equals 1x plus 1. Well, watch what happens if I change m, the m right here. Watch what happens if I change that to be larger, larger, larger. You see why that's, do you see how that's affecting the slope of the line? If it's 0, then there's no slope at all and it's flat. If it's negative, then it kind of takes off up the other direction. So you can experiment and see that, yeah, that number is actually, it tells you something about the slope of the line. I'll show you something even kind of more powerful. So let me set it to 2. So right now the slope is 2. Well, if I go to some point on the graph, let's go to this point right here. I'm at that point right there. Notice if you rise 1 and run, rise 1, 2, and then run 1, notice that slope really is 2. Like that isn't just affecting the slope, it literally is the slope. If I move this thing to 3, now look what happens. If I start here and I go up 1, 2, 3 and over 1, so it really is rise over run. It really is the slope of the line. That number is directly visible on the line. And then the B value, as I mentioned, actually shows where it crosses the y-axis. Notice the B value here is 1, and sure enough, it crosses right there at 1. What happens if I move that up to 2? Look at that, now it crosses right there at 2. So those two numbers are directly visible with the line that I draw. That's kind of neat to see. Anyway, we'll play more with that second part of the class today. So the point is, if the slope is rise over run, and I put the units, so I can see the slope here is 0.0163. If I put the units for rise, meters, divided by the units for run, years, all of a sudden I look at this number and I go, oh, wow, that actually means something really cool here. Do you notice that it's not written here, but it's kind of important to point out that's actually a positive number. So what does that slope actually mean? What's the meaning of the slope in this context? It really means the record is increasing by, I'll just round it off, 0.02 meters per year. In other words, that tells us kind of the trend. On average, that's not what exactly happened each year, but on average, the record was actually going up 0.02 meters per year over that time. That's what that trend line is actually saying. So the slope is actually kind of cool. It isn't just the rise over run, it actually means something really, really kind of powerful. And as I mentioned a little bit yesterday, that's why calculus exists, to study slope, because it isn't just rise over run. It actually tells you how something's increasing or decreasing. So, you know, right now we're looking at COVID cases and, you know, they're going up and they're going down. And anything that pertains to rate of change, that's really what slope is. So right now, this record is going up, 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 and it's going up at that rate. So that's kind of cool. Second thing, besides understanding what slope is being able to use this for something. So could you do this? So if this trend line kind of held true, then could we forecast out to the future, to the next Olympics 2024, and take a guess as to what we thought the kind of the winning distance would be in 2024? Now, as you can see, it's bouncing all over the place here. So there's, it's not like it's going to land right on this. Notice of all of the years, there's only just a few points that were actually kind of near that line. This one was way off of it. This was way below it. That was way below it. But if you were to make your best guess, that's the whole point of finding a trend line, is to kind of use it to predict the future. Then I could stick 2024 in. Well, where? So in this equation, where do I stick 2024? For X, because X is the year. So that means 0.0163 times 2024 minus 23.857, whatever that answer is. And again, I could type that in my calculator and get it, but we are using Excel and it does this stuff automatically. So why not just say, hey, this cell will equal 0.0163 times 2024 minus 23.857. So 9 meters, that's the guess. That would be, that's what's cool about that, is it's not just a random guess. That's entirely what this line would predict would happen out in 2024, which actually goes off the graph, doesn't it? Because it stopped at 2020, so it'd be kind of way out here somewhere. So that's kind of cool that you can use algebra to actually produce a guess as to what that would be. And so that's kind of fun, because notice there aren't any jumps over here that got over the top of 9 meters. As I said, 1968 must have had somebody really good, because that was a crazy year. Almost made it to 9 meters, but I would assume in the world of track and field, there's all these milestones people are trying to get. I mean, there's the 4-minute mile was a thing for a long time back in the day, and if that hasn't already been beaten, I'm sure trying to get over 9 meters is like that. And this prediction would say, well, if things continue like they are, still improving over time as training methods get better and so forth, this is the distance you'd predict. And of course, it'd be good to put meters on the end of that. So anyway, not hard to make a graph and to then be able to use the equation for something. So what I wanted to give you some time to do now is just turn loose to do these next 2 problems. So just to quickly make sure you understand it, you would probably think, we got a test coming up tomorrow, you'd probably assume that minutes studied would make a difference on your exam percent, wouldn't you? You sort of hope so. And so let's say somebody did a study on, this is how many minutes each person studied, and this is the exam percent that they got. So again, I find myself overwhelmed by looking at all the numbers. I'm not really sure if there's a relationship. And if you make a scatter plot of this, you'll be able to see if there really is some kind of relationship. Now, will there be students that didn't study that much and got a really good grade because they're really naturally smart? Are there students that would work really hard and study a lot? Like this person studied more minutes than lots of these people, but only got 63%. So, that kind of thing is going to happen too. But, is there a relationship there? You'd kind of think there would be. Notice I'm asking for the R value for the equation. Yeah, and I'm not going to mess with you on that. The independent variable, the X, will always be on the left, because you would have control over how many minutes you study, but then what should follow from that is, a better or worse percent grade on your exam. So yeah, I'm going to put them in the right order. I'm not going to mess with that. And then I showed you something about this second one. So notice I asked for the slope and its meaning. And then I showed you something about this global warming kind of a scatter plot the other day. So this is just another question that pertains to that. So I'm just going to shut up, give you a few minutes to ideally be done. I mean, do this now. I'll probably give you at least 30 minutes here. Maybe you'll get completely done with this and that'd be great. And I'll just walk around and give you a hand. No, you found it. You found it. This one is it actually makes the class. Yeah. Well, this you just don't have control. What I know. Most manual. But the problem, the problem. Yeah, and that's I use in those several factors. the only thing I did was I went back and you see how it always will start from 0. And I'm just looking at that. Right. Really fast. Yeah, so now that's you make a calculation. You have this equation. Your x value is equal to this. So this is saying what's the prediction for 2024, whether that's the year, whether it's that. That's the beauty of the equation. Now we can see the equation. So go down to the box. Anytime you want to use it. So I took this is the So with respect to minutes and exam scores, you should kind of see, yeah, there's a relationship, but it's really rough, right? It's not perfect because how much you study is not the only thing that affects how you do on tests. You know, the class you're in, you might be more natural at it than somebody else, and you might not have to study as much. Good. Yeah, so it's just, what that means is that's not a perfect relationship. Like it isn't just as simple as how much makes you way better. It's definitely there's kind of a relationship that is there. Yeah. So click on those data points. Click on those data points and then click. Yeah, that's right. Square root because it's giving you r squared. You got a square root of r. Oh, so it's so you can break out your calculator, you can do it in Excel. That's URT equals URT. Oh, no, I think that's just. That's actually.
Yeah, I know, yeah.
There is a command for it. If you type equals SQRT. Start parentheses.
Yeah, I do that. I did a little later today.
So the trend line. Powerful about that is the model for the relationship. True. You know what it is. The points were perfectly lined up, then we got an R value. So our value is totally correct. So this is kind of like but notice on the other, you really have to close like that. That our value. If this number Ultimately, because this is kind of hard, like this is hard for people to get. So would you agree that in this problem, I think I'll just do this from scratch. Would you agree that we don't have a good feel for this yet, but the slope is just the number that's in front of x. The second part of this class today will help make a little bit more sense of that, I hope. But so roughly it's 0.016. So great, I found the slope, but you know, again, that just feels like, well, the teacher wanted me to write that number down, so I wrote it down. Okay. I don't understand what I just did. So what does the slope mean? What is it actually telling me though? Well, because slope is rise, slope is found by taking the rise divided by the run. So I rise in this direction and I run in this direction. And so this is saying that slope is 0.016. I rise this direction, I run that direction, and that's the answer that I got. Well, what is the unit of my rise? It's meters. So this is really meters. So I'm staring at this problem just to see what the units are. Oh, this is meters. What's the run? Oh, that's in years. And so that 0.016 then has a unit. It's actually 0.016 meters per year. All of a sudden now I understand what that number is telling me. Oh, that's telling me I can actually expect the record to increase by 0.016 meters a year. That means something in the problem. That's the idea. So for exam, and let's stare at this a little bit. So you're in the middle of this one. I'm going to insert. You should be able to tell at a glance that that's not very good correlation. That's much more scattery. And so when did you get this answer? When you add your trend line and your equation, did you get, make this nice and big so you can see it. If you just change the font of it. So I have it clicked right now and I'm going up here to the home screen and just increasing the font size. So again, would you agree that my slope is 0.591? And you're sort of taking that by faith, right? I'm just telling you that's what it is. But... Exactly. So what's the unit? What are the units here for rise over run? Well, this is percent and this is minutes. And in that sense, I can say, oh, now I see what this means. Basically, my exam score, what this is telling me is my exam score will increase by I'll just round it off, 0.59% for every extra minute I study. So I'm giving you that one. So this is telling you something very practical. So I'm getting about 0.6% increase, because that's a positive number. For every increase of a minute, I'll get an increase of 0.6% on my exam score. But I want you to notice something here. I'm going to type this equals SQRT square root. So the R squared value is 0.6176. So notice the R value here, and I want you to get a feel for this. Notice it's only 78%. So basically I'm making predictions here. Like here, you're making a prediction. If I study for 54 minutes, then what exam grade could I expect to get? Well, you only have sort of a 78% chance that your prediction's really going to be true, because this isn't a very good relationship. It's definitely increasing. I mean, it's definitely showing an upward trend. There's definitely a relationship between how much you study and how much your exam score is, but it's not perfect. It's only 78% accurate, this relationship. And so, when I make predictions about it, 78% chance that my prediction will kind of come true. When this percent is like 99, then you can count on it a lot more, but here it's only 78. So the fact that in this problem, the R value was 90% means that my prediction here of 9 meters in 2024 kind of has like a 90% chance of being true, of coming true, because this relationship is 90% accurate, 90% kind of defined by this line. Whereas when I move over here, it's not quite as good. It's only 78%. And you can see the points are jumping all over the place. So I don't feel very confident about my predictions, but it's kind of cool because it's the best that you can do. So the real purpose of statistics is to make predictions. It's not just to report on what happened yesterday. It's to try to predict what's going to happen in the future. So slope's kind of a cool thing. It's not, this isn't something I'm asking you on a test, but it's kind of cool to understand what slope means. Anyway, I'm going to give you another, I don't know, 5 or 10 minutes, and then I'll show you some other things, and then you can keep working on this after that if you want to. Let's take a look at this together. I'd like to just give you a little bit of background, and actually, we're not gonna be doing algebra for this afternoon session. We're not gonna be doing this kind of all term long. Like, we're getting pretty close to the end of algebra stuff that I'm gonna show you. But I'd like to increase your understanding a little bit as to what's kind of going on here. So let's play with this a little bit, and then you can go back and work on your other. I just want you to have a sense that it is possible that this magic line that your graphing calculator and that now Excel just produced this line for us. I just want you to see that you can kind of do this yourself. And I want you to have a sense of what this really means. And so staring at this, years of education and income. So this is years of education down here, how much education you get, and this is money over here. So I've been telling you that this is sort of the way that this gets thought of. In the end, all lines look like that. Y equals something, some number times X plus some other number. And M is the slope of the graph, which is rise over run. And B is the location where it crosses the y-axis. Does it make sense that you could actually make a rough equation for this just without kind of using a machine and so forth? You could make a rough equation of this. I mean, what would you say, as I said right here, estimate B from the trend line? The B is the location where it crosses the y-axis. I mean, what do you think that is right there? Notice it's not, I can't tell perfectly, but what would you say? What would you say is the point where that crosses right there? What is each box worth? Let's see, this is 500, so it's 1, 2, 3, 4, 5. Yeah, what do you think? Yeah, like maybe that's halfway. So maybe that's negative 550. And you could argue, no, I think it's 555 or 540 or something like that, but it's around negative 550. So we've been using, regression or kind of a magic formula that the computer and the calculator have been doing this for us. But it's not like I can't just kind of look at this and see, hey, it crosses right there. Here's the original data points. Notice there's 6 of them, and then the lines drawn through them. I draw this line through them. Well, I can estimate that. Now, notice what I said second. Pick 2 points that the line passes through, and I said they don't necessarily have to be the graph points. Would you agree that this one is actually pretty decent? But again, I'm looking for places where it really crosses in a nice, easy place for me to count. This one's not bad. Do you agree with that? Is there any other ones that are pretty good? This is a pretty hard line. It looks like it's kind of missing all the points. I'm going to go with these 2. That's the 2. It looks like it crosses the closest to me. Well, if you understand that slope is rise over run, I mean, you could just count them. I'll show you a better way in a second, but rise. There's the rise. 1, 2, 3. There's the run. 1, 2, 3. Now, the only problem with this is what are those boxes worth? What's a box worth down here on the x-axis, and what is it worth on the y-axis? See, those boxes are not worth the same thing. Down here on the x-axis, it goes 10, 11, 12, 13, 14, 15, like each box is worth 1 year. So this is actually 3 years. But over here, each box is worth not 1, but 100, right? 100, 200, 300, 400. So when I was counting up, it wasn't really 1, 2, 3. It was 100, 200, 300. Does that make sense? So this is actually not so much 3, but $300. So what's my slope then? Since it's rise over run, that'd be, if you leave the units in it, $300 per 3 years. Notice that fraction reduces. What does 300 divided by 3 reduce to? 300 divided by 3 is 100. So this is basically $100 per year. That's what your slope is. Again, it's kind of cool to understand that has a meaning. The slope itself is around 100, but it's kind of cool to understand it means $100 per year. In other words, every year of education, you get $100 more, basically is what this is saying, what that slope is telling us. Now, you can just count it, but notice the rise can be found by subtracting their y values. Like I just counted it on the graph, but let's do this a little more sophisticated than that, maybe. So I'm gonna label these points. Like what is that point? Well, notice it's 5, 6, 7, 8. So that's 8 for x. And then over here, it's at 300. Do you agree with that? So the coordinates of that point are 8, 300. So 8 years of education, you get $300. I think this is per week or something. And then this point over here that we found, that's 11 for x. I can see 11 right there. And then it's at 600. So the cool thing is you don't have to count it. You can just do the math. So the rise can be found by subtracting their y values. So if I go 600 minus 300, y value minus y value, I get 300. That's the same 300 we just got a second ago by counting them ourselves. And the run can be found by subtracting their x values. If I take 11 minus 8, 11 minus 8 is 3. That's the same 3 we just got a minute ago by counting them ourselves. So then the slope, being rise over run, is 300 divided by 3, or 100. So now that I know, now that I have a value for b up here, and I have a value for the slope, then couldn't I say the equation of the line, y equals the slope times x minus, does it make sense? I just did that by hand. Like, it's not magic. What your calculator is doing is really cool. But this is going to be pretty close to the same thing the machine would have given us. That's kind of the idea here. So you can actually get this stuff yourself. The thing I want you to understand that's amazing about the calculator, though, is would you agree that that point that I was looking at there, like that actually does not go right through that point? It's the closest one I could find, but it actually didn't go through the point. So I was doing the best I could. What's cool about your calculator is it takes all 6 of these data points right here, 1, 2, 3, 4, 5, 6, and it considers all 6 of them and sort of averages them and makes the perfect equation for the line and the slope. And it won't be exactly the same as what I get doing it by hand, but at least doing it by hand, I have a sense of what the calculator is actually doing. I just guessed it. In other words, knowing that B is the location where it crosses the y-axis, I just looked at this trend line here, and I said, to me, that looks like it's crossing at negative 550. It's just an approximation. Is it perfectly negative 550? No, but it's pretty close. So let's see, I used to know how to do this. So let's kind of do something from scratch here. So I'm making a random graph right now. And see, I'm going to graph some points. I won't bother to make this one practical. I'll just let each box be where it is. So I'm graphing those 4 points right there. Let me tell you what they are. This is the point 2, 4, 2, 4, 6. So this is the point 7, 1, 2, 3, 4, 5. This is the point 9, 2, 4, 6, 8, 10. So this would be 9, 11. Eight, 10, 12, 14. So this is the point 14, 12. So there's those points. Now, would you agree that I'm guessing at this, but would you agree the trend line for this might be, I don't know, right there? That look like a decent guess? Now, is my guess perfect and mathematical? No, this is not as good as Excel will do or as your calculator will do. Your calculator considers all those points. But let's do this all the way. So there's my rough trend line. So my question to you is, can you find the equation of that line? Now let's pick some points that it looks like it crosses. Notice none of the points even touch the line at all, but the trend line goes through them, and so that's decent. So to me, this one looks pretty good. This is the point 2, 3. That point goes through. This one right here is not too bad. What's that one? I guess that's 10, 10, 10. So does it make sense to you? Because I see those 2 points that I can just make my own kind of rough estimate for what I think this trend line would be. So we said the slope was found by going rise over run. Y minus y, so 10 minus 3, this 10 minus this 3, that's y minus y, over x minus x. This 10 minus this 2. So I got 7 over 8. So do you agree that my slope is, I could make a decimal out of that, but that's my slope, 7/8. Could I have counted that? Just counted it myself and not went to all that trouble? Sure. Rise 1, 2, 3, 4, 5, 6, 7. Run 1, 2, 3, 4, 5, 6, 7, 8. That's where 7/8 came from. This y minus y over x minus x is just kind of a cool formula. It allows you not to have to count it and so forth. So I'll show you something. So would you agree then that the equation is y equals 7/8 x plus something? Well, where would you say that crosses right there? Notice it's kind of hard to guess. Certainly above 1. It looks less than halfway to me. It looks under halfway, so maybe I'll call it 1.3. Does that seem reasonable? So there's a rough equation that I found for this line. But what I would like to do now, I'll have to switch back and forth a little bit for this. Actually, maybe I can do it on here. Actually, I'm not sure. I'm not sure that's going to work. So why don't you do this? So you're already in Excel right now. Like, go off to the side somewhere and put those ordered pairs in Excel. So 2, 4, 7, 5, 9, 11, 14, 12. Just put those ordered pairs in cells and ask, and you go make a quick scatter plot of it, and you ask it, what's the regression equation? I want you to see that you'll get something kind of near what we just got. It's not just magic, is my point. I'm going to do this on my graphing calculator, so I don't have to take that away. Could have also had you do this in your graphing calculator. I just did this in my graphing calculator. You can check what you got with Excel. But I got y equals 0.73 approximately x plus 2.2. Is that what you got? So a couple of things. So this is by far the best equation. Why is it best? Well, because it considers all 4 points. Notice a second ago, I just chose the best 2 that I could find and did the best that I could do. But this was best because it's way more accurate, but also because it wasn't near as much work. I had to work pretty hard for this answer that I got up here. Do you see though that they're similar? Like, why aren't they the same though? I thought we looked over there and said it looks like it crossed at 1.3, and this is saying no, it actually crosses at 2.2. How come it's like that? Yeah, I mean, isn't this line that I drew here, like that was just a guess, right? I wasn't doing that based on math. I was just kind of eyeballing it to look the best that it could look. And so basically it must be saying something like this. 2.2 must be saying that the right, maybe when they did it mathematically, if you will, the real line, looked more like that. So that's what your calculator is doing. That's what Excel is doing. It's actually considering all of these points and finding, using the complicated formulas that are on your note sheet. It's finding R and finding finding this y hat or regression equation entirely based on mathematics. But it's kind of cool to see that I can at least get close. So, where I thought it crossed wasn't perfectly the same, but it's not like they were way off. And 7/8 is 0.875. Notice that slope is, I thought it was steeper, and they're saying it isn't quite as steep, but you can at least see I'm in the ballpark, right? So notice the green line that I drew up here is not quite as steep. The green line is not as steep as the red line, so it's going to have a smaller slope. And so that's kind of what they're saying. They're saying, no, the slope is actually smaller. So this regression thing is kind of neat, but it's not that you can't understand it yourself. I am not going to ask you on a test to find equations of lines yourself. But that's one of the things you missed just jumping into this class kind of without reviewing some algebra, is the ability to find equations for your lines yourself. And the downside of that is, when you're learning this, it sort of feels like magic, like you're just clicking the buttons I'm saying to click, and then you're getting equations, and it's like, I don't understand what this means. But again, the concept is just, hey, I found a line that's kind of a trend line that matches this data the best it could be. And if the data is interesting or important, then I can use that to kind of predict things. So that I am going to ask you. So on the test tomorrow, I'm going to give you, points like this, something in context, points like this, and then ask you to predict something, find its equation, find its R value. And I'm assuming you're using your graphing calculator for that. But you get the equation for free, but you do have to be able to use it. So anyway, that's a little bit of background. I really don't want you to be, any better than that. And so that's the idea behind these last questions down here. Once you have an equation for something, then can you use your equation to estimate the income for someone with 20 years of education? You should be able to say, oh, 20 years of education, that's X. So this is kind of code for X. Therefore, oh, okay, 100 times X is 20 minus 550. That's going to tell me the Y value. Y was income. The second question says, use your equation to estimate the number of years of education required. And I think this is actually a more natural question, because this person wants to make 340 bucks. So that's income. So that's basically, you have to be able to read the equation well enough to know that, oh, $340 of income because of the units. Because the units up here, this was income. Oh, that's Y. Okay. So now I know where to plug 340 in. I've got to plug it in for Y. And that's a little more trouble, right? If I'm staring at this problem, I'm thinking, oh, that's not hard at all. I just need to type that in my calculator, 100 times 20 minus 550, and I'm done. Whereas this one, that's a little more trouble because I got to solve for X. but we're actually answering questions somebody would want to answer based on this relationship that we, well, quantified. We put numbers, we put an equation to this relationship. So now we kind of have a sense of what it is, and we can actually mathematically come up with guesses and estimates for something that we want to know about. So that's what's so powerful about finding an equation to model something. Again, you don't owe me this. You don't have to turn this into me. But I do want you to at least understand it a bit. Okay, so rest of the time you can jump back on your lab and try to finish that. You're also welcome to ask me any homework questions or anything after the test review. We'll review for about a half an hour tomorrow at the start of class, so like from 8 to 8:30, and then we'll take off, turn you loose on the test after that.